now we're going to look at part 2 of the pivot tables in Microsoft Excel. I'm going to show you how to do some additional steps and analyses utilizing the power of pivot tables. What we're going to focus on is the Pareto Principle. I'll explain it, give you a general summary of what it represents in the real world, but also suggest that it also applies to baseball. Then we're going to create a Pareto chart in Microsoft Excel through the use of pivot tables, and we will do this with the objective of answering some statistical questions. So the Pareto Principle has actually been around for a long time, comes from economics, and it's named after its inventor, who was an Italian economist. And the basic idea is that 80% of your problems come from 20% of the parts, or 80% of your sales come from 20% of your clients. In the context of baseball, you can think of it as 80% of a team's productivity comes from 20% of your players. Now, the Pareto Principle is a rule of thumb. It's an approximation. In reality, it may not be exactly 80% or it may not be exactly 20%, but it gets close. So as you can see from the pie chart on the right, one example of how this plays out in baseball is in wins above replacement. So what it says is that the top 15% of all players produce 85% of wins above replacement. In other words, the talent and the contribution is concentrated upon the top 15% of the players in the major leagues. So we're going to see how the Pareto Principle applies to other measures in baseball, in particular home runs. So what we're going to do is generate some Pareto charts, which is both a bar chart, which is the blue colored chart on the right, this is the bar chart, and then the line graph, which is the orange colored line. And what the orange colored line represents is a cumulative total of the information in the bar chart. So you can quickly see the increase of contribution from the small number of factors. And you'll see these kinds of Pareto principles play out when there's a high concentration of contribution from a small number of people. So here are the two statistical questions that we will focus on. What percentage of the players contribute 80% of a team's home runs? And just as an experiment, we're going to compare what percentage of the players make up 80% of a team's payroll, because I know that the distribution of pay on a baseball team and on most professional sports teams is significantly skewed, meaning that a small number of players receive a large amount of the payroll. Okay, so focusing on the first question regarding home runs, let's go back to our layman database, and you recall that from downloading it, it gives you a single folder that can then be expanded into all of the data files in the database. So we are going to begin with the batting database, and we are going to create a pivot table first, and then we're going to generate the Pareto diagram. So again, I'm selecting all the data, and I'm going to create the pivot table again, and this is going to give me the ability to look at the number of home runs that have been hit. I'm going to recreate what was done in part 1 video part 1 just so that we are on the same, working off the same sheet of music. So what I had started with is focusing on the year 2016. So I'm going to unselect that and only select 2016. Okay. Now the year becomes my filter. I'm only interested in the data from 2016. And I'm only interested in home runs. So I'm going to drag that into values. And I actually want the sum of home runs. So there are a total of 5,610 home runs hit in the year 2016. Now, by whom is, as you recall from part 1 of the video, we had recognized that there was one particular team that hit a lot of home runs, which was the Baltimore Orioles. So let me show you again. This is all the data. This is alphabetical. So if I want to rearrange this, I'm going to resort this from largest to smallest to again demonstrate that Baltimore had the largest number of home runs. Okay. Since we're only going to focus on Baltimore, what I want to do is make the team itself. I only want to focus on one of the 30 teams. So I'm going to go to that field, unselect, and then only select Baltimore. Great. So there's my team, the Baltimore Orioles. Now I'm going to decompose this information, drill down a little bit farther by saying I want to know the players within the Baltimore Orioles who hit home runs. So here are all the players. I did that by dragging player ID down to rows. And again, I want to see this in order from largest contributor to smallest contributor. So I'm going to right click and hit sort largest to smallest. And just like we showed before, Mark Trumbo had the highest number of home runs in the year 2016. So this is where we stopped last time, and in order to go beyond this and draw the Pareto chart, what I'm going to do is drag home runs down to the values section again, and I'm not interested in count of home runs. I am interested in the value settings. I'm interested in the sum of home runs. So what I've done here is essentially have created identical columns. These have the same exact information. But what I'm going to do now is I'm going to change what is being displayed about that data. I'm not changing the data itself, but I'm just changing what is being displayed about it. So I'm going to right click on this column and I'm going to say show values as, do this a little higher so you can see. Right click on this, show values as percent running total in. Okay. Before I click on it, let me show you another way of pulling up this menu. If I was to go to that second column of information, I can click on value field settings and show values as, and here are the same options. Percent running total in is what I want. And the reason I want that is because it's going to show me the percentage that this row represents of the total number of home runs, and then it's going to show me the sum of row 1 and row 2 in terms of the cumulative percentage. So this 33% is the sum of Trumbo's and Davis. The two of them represent 33%. And then row 3, 48%, is the sum of Trumbo, Davis, and Machado. Right? So on and so forth. You'll see then that by the time that it gets to about halfway down, 100% of the home runs have been accounted for. the remainder of the roster didn't hit any home runs. So it means that 100% of the home runs by this point have been already accounted for by the players in the top half of this data. Okay, so this is the table representation. Now let's create the graph. So we go to the Insert menu, Pivot Chart, and you'll see that automatically Excel already has suggested that there's going to be a clustered column, or as we called it before, a bar chart being created to demonstrate that the data in column B, that would be here, can be displayed as a bar chart. That's great, but we have two pieces of information that we want to overlay. Okay, the second piece of information is column C, that is the cumulative percentage of the home runs that have been hit. So what we're going to do is we're going to select the combo option down here, and you'll see now we can plot two things onto the same axis. And what I'm going to do is I'm going to select the second column, or column C, as the secondary axis. And as soon as I did that, you'll see that this orange line appeared. See, if I unselect that, it disappears. If I select that, there it is. And so this is my Pareto chart. It's basically showing that the contribution of home runs is concentrated amongst the top players on that team. So let's hit OK so that we can actually have this chart being generated. And I'm going to expand it so we can get a better appreciation of what the chart looks like. And I'm actually going to remove the legend just by hitting delete so that I have a little bit more room. Okay, so you'll see that the concentration of home runs is very evident now amongst the top players. I do want to point something out. For some reason, Excel defaults to a range of axes from 0 to 120%, and that's actually not correct in terms of us evaluating the Pareto chart. So what I'm going to do is, by double clicking on that axis, it brings up these options. So I'm going to just change 1.2 to 1, and by hitting enter, you'll see that it got resized and my maximum is 100%. So that is the maximum possible cumulative percentage value that I'm interested in. So this looks a little bit better. You'll see how quickly the cumulative percentage increases, and if I was to click on that orange line, it actually displays the percentage numbers that appear in the table to the left. So the first data point is 18.58%. The second data point is somewhere hidden here, 33.6, and then the third data point is 48.2. Okay, so the question that I had posed before is, what percentage of the players contribute to 80% of the home runs? So you only have to go back as far down as the 4th, 5th, 6th player. The top 6 players represent 78% of the home runs for the Baltimore Orioles in 2016. Okay, and so 6 players represent what percentage of the roster? Okay, so you'll see that there are quite a number of people on this roster. See, there happen to be, just select this and try to get a sum. Whoop. So there are 47 players on this roster. What this means, though, is that 47 players played for the Baltimore Orioles. Some of them got traded, so only maybe played a few games. But if we were to just make a quick calculation, 6 players out of the roster of 47 represent 12%. So 12% of the roster, let me put that in that cell, 12% of the players make up 78% of the home runs. So the Pareto principle certainly applies to home runs and home run contributions. Now, let's do a similar analysis by using the salary database. So you'll notice that I have to now go to a different Excel spreadsheet called salaries, and this one contains all the salaries for all the players, and this only goes as far back as 1985. Okay, that's fine. Let's highlight all the data and create a very quick pivot table. And again, all I'm interested in is Baltimore Orioles in 2016. Okay, so let's go to year ID, select only 2016. Let's go to team ID and only select the Baltimore Orioles. I'm going to drag that down to filter. Okay, so these filters have already been preset. Now, all I'm interested in is looking at the salaries. There are 29 players who received a salary that year. I'm interested in the sum. Okay. And I'm going to drag player ID down to rows so that you can now see the salaries that correspond to each player. Okay. So some of these salaries are round numbers, some of them are not, but it's okay. Here are all the salaries for the Baltimore Orioles in 2016. Now, again, we're going to reorder the data in order of largest to smallest. You'll see that a couple of these guys get paid quite a bit of money. So here we have Davis, $21 million, Miley, $16 million, and so forth. Trumbo is all the way down here. He's only bringing home a cool $9 million. So let's draw, we need to create an additional identical column right next to it, also from the salary data. And I'm interested in the sum of salary, but I want these values to display as percent running total in. Okay, so you'll see that Davis represents 13% of the salary. Davis plus Miley represent 23%. Davis plus Miley plus Jones represent 33%, right? You get the hang of it. So now let's make this into a Pareto chart and see the visualization of these results. So I'm going to go to Insert, Pivot Chart, and again it defaulted to the bar chart, which is great, but I want the combo option again so that I can overlay the second piece of information, which is the second column I created, the sum of salary, which is a cumulative percentage of the data. So I'm going to hit OK on that. I'm going to delete the legend just to have a little bit more room, and I'm going to make this bigger so that we can take advantage of the visual result. And then I'm going to again double click on the y-axis, and I'm going to correct the fact that I'm only interested in seeing a maximum of 100%, not 120%. Enter, and then X that. Okay, so we look at the data here and we try to get as close to 80% as possible, so right around down here. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the top 11 paid players make up about 80% of the payroll. Okay, and it seems like, sorry, I accidentally clicked on that. So it seems like there are how many players in this roster? 29 players. Okay. So 11 out of the 29 players, 37, let's call it 38%. So 38% of the players of the roster make up 80% of the salary. So I would say the Pareto rule also applies here, and not as accurate, not as similar to the 80-20 rule, where it would be sort of a rigid thing to say that 80% of the salary is made up, is consumed by 20% of the players. Is not exactly that in the case of the Baltimore Orioles, but I'm sure if you compared and did this analysis for a different team, you might see a different distribution of salaries and definitely a different distribution of home runs. So I hope you can replicate these steps to see not only how the Pareto charts can be generated in Excel through the use of the pivot charts, but also to be able to answer some of these statistical questions of where do the majority of the contributions and where does the majority of the compensation come to and is distributed amongst, to better understand the imbalance, in a sense, within professional sports. Have a good one.